Okay, I see where I made a little bit of an error here. So when it comes back down at 1.5 at 7, it should be not at the axis, it should be at this point of equilibrium. So this last part, I'm a little scared to erase about how much it's going to erase here. Oh, and I did the whole thing. I'll try to very quickly sketch this again then. So it starts off. I don't know why, but I need to make those little sound effects while I do this. Okay, so it crosses right about there. So very similar to what I have here in Desmos, where here in fact they show where it crosses the x-axis, and my drawing is not bad. It's just kind of out of luck because I didn't actually plot those points. So we have the graph over that interval. That part's done. So now let's go to part B. It says solve the following graphs algebraically. So you see what they did here is that instead of y here, they made this equal to 1. So I'm wondering, when is all this equal to 1? So we can do this algebraically. Well, again, what we need to do is solve for x. So we need to get everything else, get rid of everything that is on the right-hand side except for the x. So if you think of order of operations, if you think of the last thing that's happening with order of operations on the right hand side and undo it. So the last thing which is happening is this -1. So I'm going to add 1 to both sides. Okay, so now I get 2 is equal to 2 times the cos, and then of all this stuff. I'm just going to leave that for now because I'm not going to work at that yet. But this 2 here is multiplying all that cos. That's the next thing that's happening order of operations. So I'm going to divide both sides by 2. And when I divide both sides by 2, this 2 cancels out here, and this turns into a 1. Okay. Now I'm going to switch sides just because we seem to be more comfortable with having our unknown with our x on the left hand side. So I'll write cos now of pi over 3 multiplied by x plus 1 is equal to, so that was 1 over here. Okay, and I should really put a second set of brackets around there. Okay, so now in my order of operations, the thing which I want to undo is the cos. So how do you undo cos? You do inverse cos of both sides. So when you do inverse cos of the left-hand side, in fact, I can even write it out. Right, I'm doing this inverse cos of this side, and I'm doing inverse cos of 1 on the. So what did I do to both sides? I did the inverse cos. So the inverse cos of cos, this cancels out. So I get pi over 3 multiplied by x plus 1 is equal to the inverse cos of 1. So what is the inverse cos of 1? So time to get out the old unit circle here. Okay, so I'm trying to find out what angle will give me on the unit circle an x value of positive 1. And so this is where I have my x value of positive 1. So my answer here will be 0, right? And also the next value would be 2 pi. So I'm going to put another one here, pi over 3 multiplied times x plus 1 is equal to 2 pi. So really now I split off into 2 different equations that I'm solving for. And at this point I'm going to undo multiplying by pi over 3 by multiplying both sides by 3 over pi. So I'll say times 3 over pi and times 3 over pi. And so this turns into 1. So I get x plus 1 is equal to, and here this is 0. And so I get an x of negative 1. On the right hand side over here, I'm going to multiply both sides by 3 over pi times 3 over pi, and in this case my pi's cancel out, and I will get, this is equal to 1, so I get x plus 1 is equal to 2 times 3, which is 6, so I get x is equal to 5. Okay, I'll change to blue here. Oh, and the other thing is, you'll notice that if I keep the same domain here of between 0 and 2 pi, my answers are within that domain. Oh, within 0 and 2 pi. So this is equal to negative 1, so this one here is outside the domain, right? Domain. But this is a good solution. Okay, so now let's go over to our second one. We're going to follow the same steps. Okay, so the first thing is we're going to add 1 to both sides. So I'll say minus 2 plus 1 is minus 1 is equal to 2 times the cos of all that. I'll divide both sides by 2. So I get negative 1 over 2 is equal to the cos of, I'll write it out, pi over 3 times x plus 1. And so I do the inverse cos of both sides here. So I'm wondering here, what is the cos, the inverse cos of negative a half? In other words, in my unit circle, when is x equal to negative a half? Negative a half up there and over there. So the reference of 1/2, that's pi over 3. And so my answer is going to be 2 pi over 3. I have two solutions, 2 pi over 3 and 4 pi over 3. Oh, I'm getting off to the edge of that line. So making some room for my work here, I will write, when I do the inverse cos of both sides, I'll say the inverse cos of negative 1/2 is equal to pi over 3 times x plus 1. So from this line to this line, I did the inverse cos of both sides. And now I'm going to have two solutions. I'm going to have 2 pi over 3 is equal to pi over 3 times x plus 1. And I will also have 4 pi over 3 is equal to pi over 3 times x plus 1. Oh, I'm running out of room there. Okay, so why does this split off into 2? Because we have two solutions, right? So now I need to get rid of everything to get at x. So at this point again, I will multiply both sides times 3 over pi, and multiply this times 3 over pi. So when I multiplied that one out here, my pi's cancel each other out, and my 3's cancel each other out, so I actually get 2 is equal to x plus 1. I may as well finish this, so x is equal to 1. Over here, when I multiply both sides times 3 over pi, to undo that, times 3 over pi, so my pi's cancel out, my 3's cancel out, and then I'm going to get a 4 is equal to x plus 1. So if I subtract 1 from each side, x is equal to 3. So here I have one solution, and this is both within the domain, so these are two solutions for x here. So that one's good. Okay, now the last part says solve the same equations graphically. If I switch to, I don't know, I guess I'll do red. If I switch to red, here I can write over top of this, you can think of this as y is equal to 1 and y is equal to this 2 cos, all this stuff. You can think of these the two sides of the equation as two different equations, and if we graph them, the solution will be, where does y equal 1 and y equal 2 times the cos of pi over 3 times x plus 1 minus 1, where do they intersect? That's how you do it graphically. So looking back at my graphical solution over here, so if I go up and find where y is equal to 1, y is equal to 1 would be this one right here. Right? Okay. And actually, when I think about with our domain here of between 0 and 2 pi, I made a bit of an error as well. I should actually put a hard dot here, right? And then not have this arrow and not have that line at all. Just have a hard dot and stop it there. And here at 2 pi, so 6.28, so I guess that would be somewhere like around over here or something. I would also have a hard dot and not write that as well. So there is one solution. There's one solution when it is equal to 5. This solution at negative 1 is outside the domain. So that is the same as what we got here, isn't it? It's the same as this solution of x equals 5. And our other one was negative 2. So if I was to graph y is equal to negative 2, y is equal to negative 2 would be right across here. And where do they meet? they meet at this spot here and at this spot there. And my graphing isn't quite as good as it. You see the two solutions, but it's a little bit hard to see exactly where it is. Algebraically, I found out it should be at 2 and at 4. But if we go to Desmos, let's type this in over here, and I can add another one. Y is equal to -2, and we can see these solutions. Here's the one at x equals 1, and there's the one at x equals 3. So you see how it works for solving the same equations graphically. You might get a question, the provincial exam likes to ask these explain questions, where they'll say, explain how to solve this graphically. And what you would say is, in English words, you'd say, graph y is equal to 1, and graph y is equal to cos pi over 3x plus 1 minus 1, and the solution is where they intersect. So you just say that in plain English. Use the graph to explain why the following equation has no solution. So here's an explain question, right? So again, it would be in words. So if we go back to here, and we could say, well, y is equal to 3. That's my green line up here. It does not touch it at all. Okay, so why would it have no solution? No solution because y equals 3 does not intersect y is equal to 2 cos and all that stuff. Okay. Another thing you could say is the maximum of this is just 1, and 3 is larger than the maximum. Okay, it's another way of explaining it. I'm going to skip example number 2 right now, but I may refer to it, I'm not sure. But I really want to get to example number 3 because this is the important stuff. This is the application to things that are happening in real life. So this is an example from Winnipeg, and they say here the average daily maximum temperature in Winnipeg follows a sinusoidal pattern. So that means typically then if I say what was the average daily maximum. So today our daily maximum, boy, it was a cold day, was minus, I don't know, minus 10 or something on average. So if you took a number of years and you figured out what the average maximum was, it would be changing. So if we start our year, if this x-axis is time, and if we are doing this in days, not in seconds, but in days, what we're going to do is we're going to count 0 as January 1st, okay? Or maybe, well, 1 would be January 1st, pardon me, and then the 15th day would be January 15th. So this whole cycle would be 365. So the first thing you know is that the entire year is going to be 365. And we're going to get some type of a shape. Let's just think about it. In the wintertime, it's very cold, so we're going to get a minimum somewhere around here, and then it's going to go to a maximum, and then it's going to come down towards a minimum. So that will be our entire period. Well, let's talk about that. So we just said the period is going to be equal to a 1 year, so it's going to be equal to 365 days, and thus our b would be equal to 2 pi divided by 365. And I think we can leave it in that 2 pi over 365 because we can't divide both the top and the bottom by 2, and I don't want to work with decimals. This is better. Okay, so on January 15th, so when this is 15, I'm just going to do a sketch here, and then we'll do a better one later, a little bit later. At January 15th, then what did it say? The lowest value was minus 14. So here we get a minus 14. So there is a dot. Okay. Later on at July 15th, which they do a little bit of work for us, they say, well, that happens to be the 196th day of the year. Well, if that's 300, that'd be one, so it'll be somewhere like over here. Okay, so this is number 196, and that would be my maximum. If this is minus 14, this is plus 26, so maybe we'll put it up over here just to get a sense here. This is 26. And so here's our minimum, there's our maximum, so we're going to get some type of a shape that looks sort of like this. Okay, oh, got to come down. There we go. So this is one period. Okay, our max value, again, is going to be equal to 26. Our min value is going to be equal to minus 14. just like on our graph there. So what will the middle be? So the middle is, clearly someplace over there. It's going to be halfway between 26 and 14. So my d value is going to be equal to the average of these two numbers, 26 plus negative 14, all divided by 2. So let's see, 26 plus 14 is 12. 12 divided by 2, I think, is 6. Let me just get on my same page here, so I get 6. The amplitude, so if I fill this value over here, I got a 6 for my value. This is 20 upwards, the amplitude, and that's 20 downwards. So it works out my A is going to be equal to 20. What else do I have to figure out? Oh, I got my A, my B, and my D. Now I need to figure out my C value. Okay, I guess the question is, are we going to use sine or cosine? And it says right here, we should use cosine. So just a reminder how cosine works. Cosine normally starts at a maximum, right? And so my C value is how much to the right it had to get moved. So in our example here, it seems to me that it got moved over exactly 196. So my C value is going to be equal to 196. So we're ready to make our sinusoidal equation for this. We got our A, B, C, and D. So we can say, well, before we say y, we should say what our numbers represent. Okay, so let y equal the daily maximum temperature in Winnipeg. And just to be thorough, we'll include our units. And the temperature is in degrees Celsius. Okay, and let x equal the day where January 1 equals 1. Okay, I think that makes it fairly clear. So now we can say this: y is equal to my A value is 20 multiplied by the cos of, now my B value is 2 pi over 365 multiplied by x minus the C, which is 196. I've got to get the right number of brackets, 1, 2, 3, and then plus 6. Okay, so there we get our nice answer. Okay, so now it says find the average temperature on October the 27th, which is the 300th day. So in other words, y equals question mark when x is equal to 300. So y is equal to 20 times the cos of 2 pi over 365 multiplied by 300 minus 196, 1, 2, 3 brackets. Oh, then I better put a third bracket there. 1, 2, 3 brackets, plus 6. Now, if you do all that work, I really recommend use your calculator. Try it now, because it takes a little bit of work. Remember, you are in radians, and you should get it around 1.6 degrees Celsius. Okay. There is your homework for today, and we'll be working on that. I do want to point out to you that there will be, look at that, a bit of an assignment coming up to do these applications of periodic functions. This is in the case for the seaport, for the level of the water as it goes up and down. It's sinusoidal. And here's another one with the level of water. And then we have this assignment with pedals on a bike and a Ferris wheel and tides and a classic, is this a mass on a spring? A spring modeling? Yes, mass on a spring. And another one with water. So you see the variations that we usually get. Okay, thank you very much.